We're going to start with number 28. And basically, it goes back into problems we've already done, but we didn't do everything on those problems. So if I look at A on this problem, what I have written down is what they gave us. They gave us that sine of 30 is 1/2. They gave us tangent of 30 is root 3 over 3. And so they want us to find cosecant of 30. And that one's just supposed to be a real simple one, right? This is the reciprocal identity. Cosecant is a reciprocal of sine. So we take sine 1/2 and we flip it over, so cosecant is 2. Okay, it's supposed to be real simple there. Now, the next one, C, they want us to find the cosine of 30. Now, the information we're given is that sine is 1/2 and tangent is root 3 over 2. So this is where we go back and we look at our identities. Okay, remember I gave you that in PDF form so you could easily see it, right, and go back to it and use it. So we have the identities, and I have sine and I have tangent information. I'm trying to find cosine. So there's a couple different identities I could use. What do you guys think about identities that I could use?
But wouldn't you just know?
The one that has all 3.
The one that has all 3, so tangent equals sine over cosine? There's that one. That's an identity. Tangent of 30 degrees equals sine of 30 over cosine 30. And this one would be okay because sine, we know tangent, so the only thing left is cosine, which we only want one thing left, right, after we put in what we know. So that one would work. What else would work? Do you remember what I said the number one used one is going to be?
The Pythagorean.
The Pythagorean identity. Sine squared plus cosine squared equals 1. Okay, so I know what sine is. Sine is 1/2, so I have 1/2 squared plus cosine squared equals 1. And now I just have to do my math. Okay, 1/2 squared is 1/4. Okay, subtract 1/4. So now cosine squared of 30 degrees equals 3/4. Get rid of the squared, I square root both sides. On top I'll have the square root of 3. On bottom the square root of 4 is 2. So cosine is root 3 over 2.
Why'd you have to go through that
No,
if you
if
just
I
know?
couldn't just take the tangent and then the
Okay, so first off, why did I have to do that when I just know, right? Because we already know 30 degrees. We already know it's root 3 over 2. We're practicing here. Sometimes you don't already know, so this is practice even though it's with angles we already know, number one. Number two, why couldn't we just set up a triangle? Is that what you're saying?
Well, why can't you just look at it? Like tangent is whatever tangent is, and sine is opposite over hypotenuse. You know, why can't you just take those numbers
Right.
and put them in
And so what we're trying to do is we're trying to use identities and not anything else. So yes, we could have used what we know about triangles. We could have used all kinds of things, but we're trying just another route to being able to do this stuff. Yep.
In case if we get a weird angle?
Yeah, if we get a weird angle or we get something that we can't make a triangle out of, all kinds of stuff. So we're just practicing using our identities. Okay, so I want you to use identities for all of this. On your board problems, on anything we do right now, I want us using identities. Okay? Okay, let's look at 31. So on number 31, we are told that the cosine of alpha is 1/4. So this is one where you don't know much, right? You don't know what alpha is even. Cosine of alpha is 1/4. And we're supposed to find, let's find the secant of alpha. What do we know about secant? It's what? Not use the right word here though. The reciprocal. So we're going to flip it over. We get 4. Okay. We're supposed to find the sine of alpha. What do I use if I know cosine and I want to find sine? The Pythagorean identity. I told you, we're going to use this one a lot, right? Sine squared of alpha plus cosine squared alpha equals 1. So I replace cosine this time with 1/4. Remember that's being squared though. So I've got 1/4 squared equals 1. So sine squared of alpha plus 1 over 16 equals 1. Subtract 1 over 16. Am I going too fast?
No.
I know if you're trying to copy, it might be going too fast. Okay, so I subtract it from 1, and now I have to square root both sides. So sine of alpha equals, 15 doesn't have anything that you can square root, so that stays the same, and the square root of 16 is 4. Okay? So when you're doing one of these problems, we're trying to show that one side equals the other. Okay? So you start with your more complicated side, and I'm going to write that one down. So notice I'm not going to write down secant at all, I'm just writing down the left-hand side. And now I'm trying to do math that gets so that my cosecant times tangent, I'm trying to show what that equals. So, ideas of what I can do to start doing something.
1 over whatever the
So what is cosecant? 1 over?
cosine.
No, sine.
Sine.
Okay, so
Oh,
we're
cos-
changing things into terms of sine and cosine. A lot of times it's going to help you. So change things into sine and cosine. So cosecant is reciprocal of sine. So we can replace cosecant with 1 over sine. And then, what about tangent? Can I replace that with anything? Okay, I could put 1 over cotangent. However, we're going to turn these things into sine and cosine.
Sine over cosine.
Yeah, tangent, remember the quotient identity?
Yep.
That was the second grouping, I think. That says that tangent is sine over cosine. So I'm going to replace tangent with sine over cosine. Okay, what happens when I do that? The signs cancel. So I am now left with 1 on top and cosine on bottom. Now it's always a good idea to keep in mind, what are you trying to get? What are we trying to get in the end? Secant. So I have 1 over cosine.
So you have to.
That is
okay.
secant, right? That is secant. Secant is 1 over cosine. So I can just say this equals secant. And now I'm done.
Oh, so you had to use the identities because that's what I was. Just
Yes, you have to use the identities. It is a must.
We aren't solving anything.
Nope.
We're just proving.
Right. Exactly. We are not solving anything. We are just showing that one side equals the other side. It's called proofs, or showing that both sides, or verify both sides equal each other. So it's like the roadmap. Remember how I talked about the roadmap? Okay. You start on one side, and then you do the math to show how you get to the other side. All right. Let's try number 62 then. So number 62 has cotangent theta plus tangent theta all over cotangent theta equals secant squared. Well, this looks a little bit scary. All right.
Don't those ones cancel?
No. So let's write down the complicated side. So Matt really wants me to cancel out the cotangents, don't you? You really want me to do that?
You can't though.
You can't, why not?
I don't know. What does one have to be negative? I don't know.
To do any simplification like this, you have to have cotangent in all of them. I'd have to be able to cancel it in the tangent also. I'd have to be able to cancel it there, and I can't. So, please do what I'm asking you to do. You're not gonna, are you? Oh, that's a bummer. All right. So, now I have to rewrite it all. Thanks, Matt. All right. So that's not an option.
What if you change tangent into cotangent? Or you change the cotangents into tangent?
What if you...
Okay, so I'm going to repeat this because this is being recorded. So we were saying, what if we change cotangent to tangent? Or we change tangent to cotangent? That seems logical, doesn't it? Because they're together, right? They go together all over the place. And we can do that. I'm afraid, though, that the math we get to on that would scare you.
What about sine and cosine?
Change them into sine and cosine?
Like tangent?
We can do that too. I'm afraid the math is going to scare you. All these ways are actually going to work. However, I'm going to make it a little bit easier on you, okay? I'm going to show you the easier way. Because what this is saying is that everything on the top is being divided by cotangent, right? So let's do that individually. Let's split it up. I have cotangent over cotangent plus tangent over cotangent. So do you guys understand what just happened? I just split it up. Now, Matt,
Now they cancel.
cotangent over cotangent, I can actually cancel them, right? Because those are the only things in the fraction. So they cancel to become 1, don't they? What about this tangent over cotangent thing? What should we do there?
Do something.
They're related, aren't they?
Yeah.
You guys know that. They're related, right? Tangent, cotangent. So there must be something magical that happens there.
You just flip it.
Look at your quotient, or your, is it, no, not quotient, your reciprocal identities. Okay, what do you see one that has a cotangent on the bottom? It is tangent, right? So they're saying if you have a cotangent on the bottom, that's the same as saying a tangent on top. Are you okay with that? Right? There's a cotangent on the bottom. It's the same as saying tangent on top. So now I have tangent times tangent. What's that? Tangent squared. Okay, now, again, back to our identities. I have 1 plus tangent squared. Look at your identities. Do we have an identity that has 1 plus tangent squared? I mean, sometimes we're lucky enough to have it exactly that way. Do we?
Yeah.
1 plus tangent squared is?
Secant squared.
Secant squared. And oh by golly, look at that. That's what I wanted, right? I wanted secant squared. So we're done.
This is one step.
Yep, on page 149, so we start with the complicated side. You don't want to start with the 1. What do you do with 1, right? Whoops. So, this is tangent times cotangent equals 1. Okay, again, identities. You have a couple ways you could go about this. You could change them both into sine and cosine and see what happens. Or you could see the fact that tangent and cotangent are very related, right? What is cotangent? Look at your identities.
Reciprocal.
Reciprocal of tangent.
1 over tangent. So let's rewrite that. We'll keep tangent as is, and I'm going to replace cotangent with 1 over tangent. What happens when you do that?
They cancel.
They
So
cancel.
you get 1.
Oh,
Do you see what I mean? Sometimes it's just one step and you're
So
done.
they're pretty much giving us the answer, but we just got to prove that that's
That's exactly what they're doing. They're giving you the answer. You just have to show how you get it.
okay.
So now we're looking at 37 on page 149. It looks like my complicated side is going to be the 1 plus cosine times 1 minus cosine. So this is where you need to FOIL them out. You either FOIL them out or use a box. Okay? And when you do that, you're going to get 1 minus cosine squared. Now, when you look at your identities, are we okay at that point? You could get to that point. Now, when you look at your identities, there is no identity that has 1 minus cosine squared, is there? And there is no identity that has just cosine squared equals something, right? So now we've got a little conundrum, right? I don't know. Well, if you look at your identities, you do have the identity sine squared plus cosine squared equals 1, right? You have that identity? Now, the reason I look at that identity is because I have a 1 and a cosine squared. In fact, this is my only identity that has cosine squared at all, right? The rest of them don't even have cosine squared. So I'm thinking, you know what? Maybe I can change this up a little bit, right? Move something to the other side, those kind of things, so that it does equal 1 minus cosine squared. Like, can I get this to match this? Okay? Can I get them to match up? So let's see here. Up here, I have 1 minus cosine squared. Down here, I just have a 1, right? So what else do I need over here? Minus cosine squared. Could I get that? Is there math that I could do to this whole equation to actually get that? So to get 1 minus cosine squared, I'm going to subtract cosine squared the other side. So it's still the identity, I'm just moving things around a little bit. So now my identity says sine squared equals 1 minus cosine squared. So now I have my identity, right? Sine squared equals 1 minus cosine squared. I've got 1 minus cosine squared here, so I can replace it with, what did I just decide 1 minus cosine squared equals? Sine squared. So now I can replace that with sine squared, which is what I wanted.
How do you do that? We just replace it.
That's
Oh,
the whole
because
point of
they're- okay, they're
identities.
equal,
Yeah,
okay.
okay. So, guys, I need to see this work down here. I need to see that somewhere on your paper when you do this, okay? Because this is not a direct identity, it's not exactly like that. I need to see your manipulations somewhere on your paper so that I know you didn't just give up and write sine squared as your answer. Not that I can see you doing that. Okay? So I need to see this somewhere. So even though you might know it's that, still work it out and show me that you know that. Okay? So a big part of proofs, you guys, is kind of showing a thought process. You're explaining to someone else how it comes about. Okay, so even though you might know this, you need to show it just so that someone looking at it, trying to learn from you, can look at it and get that. It's kind of the thought process when you do this, okay?